Hi everyone, I am Xavier Gandibleux from University of Nantes in France. I am talking about vOptSolver, which is an ecosystem for multi-objective linear optimization. So the problem targeted by vOptSolver are the following. We consider P objective function, P linear objective function to minimize, and we consider M linear constraint. And also we consider 4 cases of depending if the variables are continuous, are discrete, are a mix between continuous and discrete variables in nature, or if the problem has a specific structure. So for this 4 class of problem, vOptSolver tried to compute what we call yn, which is the set of non-dominant points. A non-dominant point is recognized into the objective space like this one, and to the set of non-dominant points, we identified XE, which is a complete set of efficient solutions. We say X star is an efficient solution if Y star is non-dominated. Let me give you an example for the 3 main classes of problem. We are here into the objective space, and for the discrete case, continuous case, and for the mixed integer case. Okay. So we can say that a point is non-dominant like this one if there is no other solution in this cone here, like this one. Then in that case, this point is non-dominated. If it exists at least one point, like here, for this point, it exists this point, then this one is not non-dominated. Same thing into when the variables are continuous, then this point, okay, is non-dominant, while this one is not non-dominant because we have here several points into the cone. For the mixed integer case, this is a little bit more sophisticated. We have several cases. We have a case when we have only an edge closed like this one or like this one. Okay, we have also an edge that we can be half open like this one, or open, have an example on this picture, or reduce to a point. Okay, then the output computed by vOptSolver are a collection of points, a collection of edge, or edge with these different cases. Okay, so vOptSolver is organized in 2 packages, vOpt specific and vOpt generic. Both have been introduced for the first time in 2017. And today they are compliant with the last version of Julia, Jump, JPK, and Gurobi. They have been tested on macOS and in Ubuntu. vOptSolver has been designed for mathematicians, for computer scientists, for engineers, and then we want it natural and intuitive for this public, for the development of new algorithms, for performing numerical experiments, and also for teaching. Okay, for that we want it easy to formulate the problem, to provide the data, to solve a problem, to collect the output, and to analyze the solutions. Okay, so vOptSolver is organized through what we call structured problem and non-structured problem. Then it corresponds to the 2 packages, and in details, then we will find here, for example, somebody that want to solve a problem with vOpt generic. Okay, he has to define the problem using jump. Then we have extended jump to in order to deal with P objective, and of course he has to select one generic algorithm, then like an EGNR, epsilon constraint, and etc., plus providing the parameters corresponding to this specific algorithm. And of course he has to provide the data, and vOpt generic return a complete set of efficient solution and the corresponding set of non-dominant point. We can solve also with the problem with vOpt specific. In that case, he has to provide, he has to select the corresponding API corresponding to the problem that he wants to solve here. Some are written in Julia, some are written in C or in C++. And then, of course, he has to provide the data, and the solver provides the complete set of non-dominant, the complete set of efficient solution, and the set of non-dominant point. Okay, through using the specific algorithm. Let me give you an example using the bijective linear assignment problem. Then this is the cost for the two objectives. And if you want to solve it with vOpt generic, like here we want to solve it using epsilon constraint method and calling GLPK as solver, then the user has to invoke jump, GLPK, and vOpt generic. Then he has to define the model, V model for vector model, okay, providing the solver that you want to use. He has to define the variables like we are doing with jump, and he has to add the objectives, then like this one for the first objective, like this one for the second objectives. Okay, he has to provide the constraint like jump, there is no change here, and he has to solve the problem in calling vSolve, providing the method that you want to call and the parameters. And he has an access to the results using these two methods for extracting the complete set of efficient solution and the set of non-dominant point. The same problem solved with vOpt specific. Here, the algorithm that we want to use is a two-phase method, an algorithm that we have developed some years ago. It is written in C. Then the user has to invoke vOpt specific. He has to select the corresponding API, providing the parameters of the problem. Then this is the two-cost matrix. He has to select the solver, okay, and just to invoke vSolve using this solver, and then he has an access to the non-dominant point and to the efficient solutions. Okay, so to summarize, this is the address for vOptSolver, the two package vOpt generic, vOpt specific, and the reference where the vOptSolver has been already discussed in the past. Thank you very much.